But I heard a footstep. All right, well, we're starting chapter 9. 9 deals with three-dimensional objects. We're looking at volume and surface area along the way. Today we're going to look at surface area of prisms. I think last year you learned about how to do volume of prisms, so this is going to be, that deals with the capacity of a three-dimensional prism. Now we're looking at what is the area that covers all the outside edges, or all the outside planes or sides of these prisms. Now remember, a prism is named after its bases. So we have like rectangular prisms. The rectangular prism, its two bases, which are parallel to each other, are rectangles. Now the rectangular prisms, every pair of bases are all rectangles, so it's really easy. Now, when we have like a triangular prism, it's made of three rectangles. However, the bases that are parallel are triangles, and that's why it's called a triangular prism. So we're going to work mainly with rectangular prisms, but there are going to be some triangular prisms that we're going to work with here. So the basic way of looking at this is when we have a rectangular prism, is that we could unfold it. If you were to imagine that we took the prism and we laid it all out so you could see all of the sides. And you see in pink, we see the bases. And then the lateral faces, those are the faces that go around. All the remaining faces are considered the lateral faces. Those are in blue. And so this is the main formula that we're going to look at. I use SA for surface area, or I could use S. And it's going to be basically, if we were to name the edges, the length and the width and the height, then we're going to use 2 times length times width plus 2 times length times height, and then 2 times width times height, and we're going to add these together. So I guess this is how I look at it. I look at it as, so we're looking at L times, LW, that's going to be, in this case, the bottom and the top. That's the LW right now. Those are the rectangles we use there. And then when we do the LH, that's going to be the back and the front. I know it's harder to see here. And then the WH are going to be your sides right here and right here. And so that's what we're looking at. We're looking at each pair. There's 3 pairs of sides. We're looking at each pair of sides. Okay. It does not matter what you call the length, the width, or the height, as long as each one of them represent a different dimension in the rectangular prism. All right. Let's go ahead and move forward. In our first example, now you're going to see them drawing the net, laying it out, having all the sides laid out. It's important that you are able to recognize that this net over here goes with this shape over here. It is important that you can find that. However, for me, when doing this, I think it's more important, when finding the surface area, that I can identify what my length is, what my width is, what my height is. I will typically say that the height is the one that is going from top to bottom. The length and the width, it doesn't matter to me what you want to call it. You can call this the length and call this the width, or you can mix it up. It doesn't really matter, because if you move the box over, it changes everything anyway, so it doesn't matter what you call it. Just identify each one of them something. And so I'm going to go ahead and write down surface area equals 2 length times width plus 2 length times height plus 2 width times height. The one thing you're going to notice is that there are 2 L's, never multiplying each other. There are 2 W's, the first and the last, and there's 2 H's, the second and the last. As long as that all of them are represented at least twice, or not at least, but are represented twice, then we're good to go. So we're going to plug in our information now, our numbers. So I have 2 times my length, which is 3, times my width, which is 5, and it's going to be plus 2, and again my length is 3, and now times my height, which is 6, and again plus 2 times my width, which again is 5, times my height, which is 6. And then all I have to do is I'm going to multiply and add everything. So you can put this entire thing into your calculator, hit enter, and you're going to get 126, and it's inches. Surface area is all the areas combined, so it's going to be inches squared. So you're going to have that work. And for practice sake, I would like you guys to write this down in your notes. I want you to have this written down. I think the practice is helpful. If I check your notes and you didn't write it down, I know you didn't listen. So hopefully you are listening. Let's go ahead and move our next page. Okay, we have two different rectangular prisms. You're finding the surface area of each of these. So go ahead, write out your formula, plug in your numbers, and go ahead and begin. All right, here we go. So for our first problem, again, we're going to write out our formula. So we have surface area equals 2 length times width plus 2 length times height plus 2 width times height. And again, the order doesn't matter. You know, as long as you have an L times something, a W times something, you know, as long as you have two L's, two W's, and two H's, and they're never multiplying each other, the order of which does not matter. So don't try to memorize this formula. Try to understand that we have three distinct rectangles, and each one of them, has two dimensions. And I think the easiest way of looking at this is we have a length, we have a width, and we have a height. And then we can plug these in. Feel free to use different colors. I think they're helpful. Again, maybe it's easy for you to look at this as everything here that's red is 2. Everything that is green is 4. And everything that's blue is 3. Maybe that makes it easier for you. I don't know. There's lots of different ways of looking at this. Let's go ahead and plug in our information though. So I have 2 times my length is 2 and my width is 3 plus 2 times my length again is 2 and my height is 4 plus 2 and my width is 3 times my height is 4. I plug this in and I get a surface area of 52 feet squared. Hopefully you came up with the same surface area. Let's try our next one. Again, we have surface area equals 2 length times width plus 2 length times height plus 2 width times height. Okay, and again, I'm going to go ahead and call this my length. I'm going to call 8 my width. I'm going to call 5 my height. I'm going to plug in my information then. So I have 2 times 8 times 8 plus 2 times 8 times 5 plus 2 times 8 times 5. Again, you notice I have 2 greens, 2 reds, 2 blues, and the colors are always mixed up. They're never the same colors being multiplied. Hopefully that makes sense to you. When I multiply and add this together, I get surface area equals 288, and it's meters, so meters squared. Okay, so far, hopefully this is pretty easy. Let's go ahead and move on to our next shape, see how we're doing on this. All right. Okay, our next key idea, surface area of a prism. The surface area S, or SA, of any prism is the sum of the areas of the bases and the lateral faces. So basically you have S equals the area of the bases, which will be 2, and then the area of the lateral faces. And that's all of the faces that go around the bases. So if we have a triangular prism, we have 2 triangles that are the bases, and since the triangle has 3 sides, we have 3 rectangles that are going to be the lateral faces. And with a prism, you're going to have rectangles. It's going to be rectangles and then whatever the bases are. If it's a pentagonal prism, you're going to have a pentagon on either side, which are your bases, and then the lateral faces will be 5 rectangles. So, just to give you an idea of what that is we're looking at. Again, basically all you're doing is you're just finding the area of each side, adding it up. That's really what you're doing. I have found that when doing triangular prisms, they can get a little tricky. And so what I like to do personally is this. I will do this formula. I'll do surface area. I'm doing the one on the left-hand. I'm doing the triangular prism up top. I'm showing my work down here at the bottom. Hopefully it doesn't confuse you. So I have surface area equals my triangles times 2, plus I have 3 different rectangles. So I have a rectangle plus a rectangle plus a rectangle. Or you can call it rectangle 1, rectangle 2, rectangle 3. It doesn't matter to me. And so I do this one a little bit differently than I've done with the rectangular prisms. Again, I'm organizing it by side. And so I want you guys to be able to show me what your formula is, plug in the values and solve. Your formula can be different than mine. You'll see that the formula they have is different than mine. They do it differently than me. This is how I do it. Okay. If you want to organize it as area, each individual area and show me the work for each one of those, that's fine. I'm just making mine into a formula. And again, the triangular prisms, the formulas change all the time based on what type of a triangle it is. Okay. So for the triangle, my bases, I'm going to go ahead and use red for that. And I'm going to say that, I need to have, you'll see the right angle is right up here. I need to have that to show me what the bases and the height. So I'm using these 2 numbers right here. I'm doing 3 times 4. So I'm having 1/2 times 3 times 4. That's how you find the area of one triangle. And then when it say times 2, because there's a top and a bottom, right? And then plus a rectangle, we'll do the first rectangle, we'll say is 6 by 4. So we're looking at this one right over here. It's 6 by 4. Now, my next rectangle is going to be the green one. It's right over here. And it is, as you can see, 6 by 3. And then finally, I have the last one, which is in the back, right? And it is 6 by 5. And it may help to look at this, the net. I don't know what's easiest for you. This is just how I do it. Now I just go ahead and in my calculator, and it's very helpful, very, very, very helpful to have a scientific calculator, which you should all have, to plug it into that. I plug in all of my information, as you see right here. And I go ahead and enter, and I get 84 meters squared. Okay. So hopefully that makes some sense to you. You're going to go ahead and try these next 2 on your own. Just go ahead and try it. All right, let's take a look at this next problem number 3. Okay, so I'm going to go ahead and write down surface area equals my triangle times 2 plus my rectangle plus my next rectangle plus my next rectangle. All right, and so for my surface area, I'm going to do, we'll go ahead and do, I'm sorry, for my triangle, we're going to go ahead and do, let's look. We have 5 by 12 right here. So I'm going to do 1/2 times 5 times 12, and then times 2, since there's 2 of them. And then plus, so for my first rectangle, I guess over here, I have 13 by 3. 13 by 3. And then plus, I have my triangle here in the back, right here. We'll say this one. This is going to be 3 high. You see how it's 3 here and it's 3 here. So it's 3 high and it's over 5. So 3 by 5. And then plus my last one, which is right over here, we'll call it 12 by 3. Again, it's 3 high, and it's 12 going across. So again, you notice that the 3 is the number that repeats for all of these, right? You'll always find that there's going to be one number that repeats for all the rectangles, okay? It's going to be the height usually, okay? So I go ahead and plug all this into my calculator, and when I do this, I should get 150 meters squared. All right, hopefully that made some sense to you. You did all right. Let's go ahead and look at our next triangular prism. So again, I'm going to do surface area equals my triangle times 2 plus my first rectangle, then my next, then my next. Okay, so I have surface area equals, and we'll go ahead and do this. We have, again, 3 by 4, right? So I'm going to do 1/2 times 3 times 4 times that 2, right? There's just 2 triangles. Then my first rectangle, I have, we'll just do this one by this one. So it's 4 by 4. And for my next rectangle, we'll do this one here on the side. So it's, again, 4 is going to be one of the measurements going across here, right? And then it's going to be 5 going up this way. So it's 4 by 5. And then plus my last one, which is going to be right down here. It's 3 by 4. And when I plug all these into my calculator, I should get 60 centimeters squared. Hopefully you came up with the same answer. All right, let's go ahead and move forward. Now here comes an easy rule. When dealing with a cube, the nice thing about a cube is that you have 6 sides that are all the same. And so we have a simple formula. We take the surface area, and it equals the area of the cube times 6. I'm sorry, the area of one side of the cube times 6, since they're all the same, which makes it really, really easy. So for our first one here on the left-hand side, every side is 12. And if it makes it easier for you to follow, just use, the S side. All of them are the same. They're all 12 in this case. So we are going to use the formula, S or SA equals 6 times the side value squared. And so all we have to do is plug in our value, which is super easy. So we're going to do 6 times, in this case, it's 12 squared. Just put that into your calculator. We end up getting 864. And it's going to be meters squared. Note over here, it says the lateral surface area of a prism is the sum of the areas of the lateral faces. Again, if we were to call the top and bottom here, I hate using the word top and bottom, but if we were to use the bases, if we pick our bases, and these are two sides that are always parallel to each other. If we choose two bases, the lateral areas or the lateral faces, they're the ones that go all the way around it. Okay, so the remaining 4 sides in this case are considered our lateral faces. Okay, why don't you guys go ahead and let's go ahead and do this one together as well. So we have a story problem. It says the outsides of purple traps are coated with glue to catch emerald ash borers. You make your own trap in the shape of a rectangular prism. Keep in mind it's with an open top and bottom. So right here and here are open. Keep that in mind, okay? These are open. What is the surface area you would need to coat with glue? So really what we're doing is we're looking for the lateral surface area. It's everything except for the base, the two bases. Okay? So in this case, we're going to have surface area. I'm going to do this slightly different. I'm going to say it's the front and the back plus the area of the two sides, the two other sides. So the front and the back, like this would be your front, and then behind it is the back. And then this would be the side, and this would be the side. Hopefully that makes some sense to you about what I consider the front and the back, and the side and the side. Or if you want to look at it how they have it here, you may do that as well. You know, you may identify what our length and our width and our height is, and only find it for those two, sides. It makes no difference to me. I'm going to do it this way. You can do it however you like, okay? As long as you write your formula and plug in your values and solve. So surface area equals, so for my front and the back, again, I'm calling my front and the back right here, okay? So I have 12 by 20. Keep in mind, though, there's 2 of them, right? And then plus my 2 sides, which we're going to say are 12 by 10, because they have it on both sides. So I'm going to have, 20 by 10. So I'm going to have 10 by that 20. And then keep in mind, all of this is going to be times 2, because there's 2 sides. I go ahead and just plug in the information into my calculator, and I'm going to get 880. And it's inches squared. And you'd want to make a complete sentence. Here's this complete sentence. So you need to coat 880 square inches with glue. Right? So now it's time for you to try these 2 problems. Let's look at them. Number 5 says, which prism has the greater surface area? So you're referring to, because yours looks a little different than mine, you're referring to these 2 prisms. So you're going to have to find the area of both prisms. One is a cube, one is a rectangular prism, and then tell me which one has the greater surface area. And then, for our next problem, the what if, you're using this part for number 6. Okay? For number 6, you're going to use this part, this purple one. Okay? So go ahead and give this a try, see how you do. Okay, well, let's see how you guys did with this one. So, which prism has the greater surface area? We're going to have to do two of these. So for our first one, the cube, I'll do this one in blue. This one we're going to have surface area equals, and it's 6 times s squared. All we have to plug in is what that s equals. So in this case, the s is 9. So 9 squared. And when I solve that, I get 486 in centimeters squared. Okay? So here's my first one. This is the cube. And for my other one, the rectangular prism, I'm going to go ahead and write down surface area equals 2LW plus 2LH plus 2WH. I'm going to use those, those dimensions, plug in my information. So again, I'm going to identify this 5 is my length. I'll say that the 15 is my width and the 7 is my height. I'll just plug in the information that I have. So I have 2 times 5 times 15 plus 2 times 5 times 7 plus 2 times 15 times 7. And I plug in my information into my calculator, and I get a grand total of 430 centimeters squared. So the cube has the greater surface area. Okay. Let's go ahead and look at the last one here. I'm going to go ahead and divide this up a little bit. So for number 6, in example 4, both the length and the width of your trap are 12 inches. What is the surface area that you use? What is the surface area you need to coat with glue? Let's look back over here. We are shown that they call the length 12 and the width 10. So we're looking at these two numbers. So we're not going to change this into a 12 inches. That's the only difference. So we're going to go ahead and do surface area equals your front times back, or your front and back, and then plus your side, your two sides. So my front and back, I've got 12 by 20, right? 12 by 20, which is right over here. So 12 by 20, and remember there's a front and a back, so we're going to do times 2, plus the sides, which again we're going to say in this case are now 12 by 20, because it tells us that the length and the width are now 12. So I'm going to do 12 by 20, and again times 2. When I solve this, I get 960 inches squared. And it says, what is the surface area needed to coat with glue? So you would need to coat 960 inches squared in paint. I know this is a long one. I apologize, but hey, what are you going to do? It's surface area. Surface area takes some time. So we'll talk to you soon, all right? Take care.
Like a star that can leave